In this example, a pharmaceutical company makes tranquilizers. It is assumed that the distribution for the length of time they last is approximately normal. Researchers in a hospital used the drug on a random sample of 8 patients. The effective period of the tranquilizer for each patient, in hours, was as follows: 3.2, 2.8, 3.0, 2.5, 2.1 hours, 3.1, 2.7, and 2.6. We're instructed to use a t-distribution. Why? Well, in fact, we know that we should use a t-distribution because, number one, we know that the sample size is much less than 30, and we're not told that the underlying population is normally distributed, although in this case, we could assume that it is normally distributed still, because we have such a small sample size, n equals 8, that we really are much safer assuming that a t-distribution should be used. Well, what about degrees of freedom? Degrees of freedom is found by taking the sample size and subtracting 1. So in this case, our degrees of freedom, no surprise, is going to be 8 minus 1, which is to say 7. So that's what we'll enter. What does the sample mean and the sample standard deviation? We are not told that we have what the population standard deviation is, so we have to go with the standard deviation from the sample. So let's go ahead and calculate that using Excel. I've entered the data here in Excel, and to find the mean, remember that you're going to find it by using the function average in Excel. So equals average, VER, you can just type that in the first few letters if you want. Double click on average. Now highlight the cells containing your data. There are 8 of them there. B2 to B9 in this case, I close the parentheses and my average is 2.75 hours. Well, that's pretty good. How about the standard deviation? Well, because it's a sample, remember that we have to use the function standard deviation for a sample. So if we start typing in STDEV, we see 2 choices right here. We see standard DEV .P and .S. We want .S. This is a sample standard deviation, not a population standard deviation. Be very careful. STDEV.S. And again, we highlight the same data, in this case from B2 to B9. And there's our sample standard deviation. So if we're entering this in our homework, we would enter in the following values here. 2.75 for X bar, right? We've got our degrees of freedom of 7 right here. So we use our standard deviation, our sample mean, of 2.75. And we're going to round our sample standard deviation right here to 2 digits, 0.36. 0.36. All right, what is the error bound mean? That is the margin of error. Well, now we need to use our Excel calculator right here, which we're going to do. Here it is. We're using a t-distribution, so that's the one in red on the top. So we're going to enter our information there. Sample size. Well, our sample size is 8. Our sample mean, 2.75. Our standard deviation, 0.36. And we want a 95% confidence interval. If you read down a line right there, what is the 95% confidence interval? So we should enter 0.95 here. Well, there's our information right there, just what we were looking for. Our margin of error, that is our error bound, is going to be, EBM is 0.3. So we'll enter 0.3 when rounded to the nearest digit. And so if we're going to find our mean time, we see that if we added 0.3 and subtracted 0.3, we're going to say that our 95% confidence interval would be 2.45. You can see that over here on the lower side. And our population mean would be less than 3.05 when we add. So that means that our drug, our tranquilizer, on average is effective between 2.45 and 3.05 hours. That's the question we were looking to answer, and so we're done.